Hi everyone, welcome you all to my channel Triple Encyclopedia. In this video, let us see about maximum power transfer theorem. The statement of this theorem is a resistive load being connected to a DC network receives maximum power when the load resistance is equal to the internal resistance known as the Thevenin's equivalent resistance of the source network as seen from the load terminal. That is, if the circuit is having the number of resistances, we are taking one particular resistance as the load resistance. So at which condition that maximum power will be transferred for the particular load resistance from the source means that load resistance value is equal to the source resistance, means at the time the maximum power will be transferred from the source to load. So that load resistance value equal to that source resistance is nothing but the load resistance value is equal to Thevenin's equivalent resistance. So before going to solve the problem related to this maximum power transfer theorem, we should that is well versed in Thevenin's theorem, that is Thevenin's equivalent circuit. So at the time of solving the problem while using this maximum power transfer theorem, we want to simplify the network in terms of Thevenin's equivalent circuit. Then only that Thevenin's the help of the Thevenin's equivalent circuit, the load resistance value is replaced by the equivalent Thevenin's resistance value. And the maximum power transfer theorem is used to find the load resistance for which there would be a maximum amount of power transfer from the source to load. Already I said that. And what is the application of this maximum power transfer theorem? Mainly this theorem is applicable for radio transmitter final amplifier stage design, and in that radio transmitter amplifier design we are seeking to maximize the power delivered to the antenna or transmission line. And also grid connected inverter, that is a grid tied inverter loading inverter loading a solar array or electric vehicle design, seeking to maximize the power delivered to the drive motor. That is at the final stage of these applications we need the maximum power. So that's why we are using the maximum power transfer theorem, and finally we are getting the maximum output at the load side. And this just we will see how to get a clear idea about this maximum power transfer theorem with some example. So here maximum power transfer theorem tells us that the load resistance resulting in greatest power dissipation is equal to value of Thevenin's. That is where we are getting the load that is maximum power means when the load resistance value is equal to the Thevenin's equivalent value. So consider this is Thevenin's equivalent circuit. It is having a Thevenin's voltage and the Thevenin's resistance, and the load will be connected at the end of Thevenin's equivalent circuit. So here notice one point, the load resistance value that must be equal to the Thevenin's resistance value. So here Thevenin's resistance value is 0.8 ohm, while the load resistance value is exactly equal to the Thevenin's equivalent resistance value, means at the time the maximum power will be transferred from the source to the load. That is the statement or definition for the maximum power transfer theorem. And see here this tabulation we are having the values of Thevenin's resistance, load resistance, and voltage, input voltage, current, load resistance, and the power value, right? Here notice one point, the Thevenin's resistance value is 0.8, again the load resistance value is again 0.8, both are same, right? So what is the maximum power obtained at load? It is nothing but 39.2 watts, right? That is the Thevenin's equivalent resistance is again equal to the load resistance value, means at the time the power dissipated at the load is nothing but 39.2 watts. Suppose the load resistance value is less than the Thevenin's resistance value. Here Thevenin's resistance value is 0.8, but the load resistance value is 0.5. So the load resistance value is less than the Thevenin's resistance value, right? At the time what will happen? The power dissipated at the load 0.5 ohm is nothing but P is equal to 37.11 watts. Suppose the load resistance value is greater than the Thevenin's resistance, right? The input resistance value. Thevenin's resistance value is 0.8, but the used load resistance value is 1.1 ohm. It is greater than the Thevenin's resistance value, so that the power dissipation at the output is what? 38.22 watts. So compare these three values of load resistances. Initially the load resistance value is equal to Thevenin's resistance, so that the power dissipated at that load is 39.2 watts, but if the load resistance value is less than the Thevenin's resistance value means the time the power dissipation is 37.11, but suppose the load resistance value is greater than the Thevenin's resistance value means at the time the power dissipation will be 38.22 watts. So compare the power values of all the three different values of resistances. When the value of load resistance is equal to Thevenin's resistance only, the maximum power will be obtained. So that is the maximum power transfer theorem. So if you need the maximum power at the output side or at the load terminals, we should replace the load resistance value that must be equal to the internal resistance of the source, otherwise the source resistance. Otherwise we can also say that Thevenin's equivalent value, Thevenin's resistance value means that load that will deliver maximum power. And just to see what are the steps we need to follow while solving the problem by using the maximum power transfer theorem. So remove the load resistance. Suppose in that question they have asked find the value of load resistance so that the maximum power will be obtained at the output. Means initially you want to remove the particular load resistance, then we want to find the Thevenin's equivalent circuit. So the this is how to find a Thevenin's equivalent circuit. Already I have explained in one of my video. I have given the link for that video in the description. So initially remove the load resistance, then find the Thevenin's equivalent circuit, that is finding the Thevenin's voltage and the Thevenin's resistance value. And finally we want to connect the load resistance, and that load resistance value must be equal to the Thevenin's, that is we want to replace the load resistance value is equal to the Thevenin's resistance value so that the maximum power will be transferred. So and the maximum power transfer is calculated by using the equation maximum power transfer, which is equal to, already we have the Thevenin's equivalent circuit. So in that circuit we are having the VTH value, that is Thevenin's equivalent voltage, VTH square divided by 4 into RTH. So this is the formula for getting the maximum power at the load side. And just to see one example for better understanding. So find the value of load resistance RL so that the maximum power is transferred from source to load. So this is the circuit. We need to find the value of load resistance RL so that the maximum power will be transferred from source to load. Already they have given the value of RL is 5 kilo ohm, but this value, the maximum power is not obtained. So that they asked what is the value of load resistance we want to put so that the maximum power will be transferred from the source to load. So for that first first step is what, just we are going to remove the load resistance. So after removing the load resistance, we want to find the Thevenin's equivalent circuit for this network, that is 48 watt, 12 ohm, 4 kilo ohm, 8 kilo ohm. For this components only we are going to find the Thevenin's equivalent circuit, and after getting the Thevenin's equivalent circuit, and finally we are putting the load resistance, and that resistance value that must be equal to Thevenin's equivalent resistance value, right? That is this is one example problem. This is not exact correct value of E Thevenin or R Thevenin, and that is in the previous one just we are reducing this circuit into Thevenin's equivalent circuit. It is having the Thevenin's voltage and the Thevenin's resistance value. Okay, so now we are connecting the load resistance at the end of Thevenin's equivalent circuit, and now we want to put the load resistance value is what, Thevenin's equivalent resistance value 0.8 ohm, that should be placed at the load resistance value. But here the given value is 5 kilo ohm. If you are putting the 5 kilo ohm, the maximum power is not transferred from the source to load. So that we are replacing the load resistance value is equal to the Thevenin's equivalent resistance value so that the maximum power will be transferred from the source to load. So after getting these values of load resistance, Thevenin's and E Thevenin value, if we need the maximum power means just use this formula, and in this formula use VTH value and RTH value so that finally we can get the maximum power will be what is the maximum power will be transferred from the source to load at the time, what is the value of load resistance. So this is only for DC network. For AC network, we are having the resistance and reactances, that is we are having the impedances. Okay, and in that impedances there are different cases are available. I am going to explain that concept further. Okay, thank you for watching. If you are new to this channel, kindly subscribe our channel Triple Encyclopedia, and share all basic concepts of this channel to your friends also.